about Hive. Hive is basically SQL, an attempt to query Hadoop clusters using SQL, basically. So what happens is we write queries, and then it is converted into MapReduce jobs, and we can do some data processing within the cluster. So how do we write this query? See, we can access Hive using any of these clients or services. Could be JDBC for Java applications. For BI application, we can use ODBC drivers, and web applications or Hive shell like CLI, command line interfaces. So this is built on top of Hadoop cluster and HDFS, and the metadata for these tables, Hive tables that we created, is stored in Metastore. Metastore consists of some services which runs on the same JVM as that of a Hive session, and the definitions of all the tables will be stored in the database associated with the Metastore. And just like any relational schema, the steps for Hive query includes creation of a table, loading data, and then running the query so that we can fetch the data out of the table. So loading data is important here because it supports multi-table inserts, which means from a single table, we can load data to multiple tables. That is possible in Hive. And originally, Hive was designed to work on top of MapReduce, but now it's possible to work on top of Apache Taze and Spark. For data models, it's a simple tables with rows and columns, and the tables can be divided into partitions with respect to the columns. Like if we specify this clause, partition by, the partitions created would be based on these two columns, like date and country. So these partitions are basically chunks which are distributed across the cluster. And the partitions are further divided into buckets. Buckets have several uses. Of course, it increases the performance. At the same time, like in terms of map joins, which the previous moderators explained, the same time, if you want to do some data analytical projects, you need to train the model using training data set. So if we have a bucket, we can select the random samples out of it using commands like table sample and do some machine learning or can train models like that. Then how Hive is different from traditional database? So when we define a Hive table and load data into it, it doesn't check the data loaded matches with the table defined. Like for example, the data type. In usual relational databases, it checks, it throws error if the loaded data is not a match with the table definition, but it doesn't do here. This is for improving the performance of loading data. So loading will be very quick here, but the query performance will be little lesser because of the huge data size. At the same time, errors might be seen if there is any errors. Yeah. And then it doesn't support in-place file updates, which means any inserts or updates that we create will be stored in small delta files, which will be periodically added onto tables, Hive tables. And third one is, like, it provides locking. So if one process use one Hive table, another process cannot drop the table. And like Hive, there are other alternatives on Hadoop, like Impala, Presto, Drill, and Phoenix, and today we learned Spark SQL. And my question is, why do we need buckets if we have partitions?
Repeat the question.
So if we have partitions, which are like subdivisions of table, then why do we need buckets? Buckets are like further division. We're dividing partitions again into buckets. Why? It's because of this. Efficient queries and sampling purposes. No candles.
mean, it can enable make it more efficient?
For example, map join. Map joins are more efficient compared to reduced join because it happens before that shuffle phase.
Right.
So if we have a bucket and the join can happen within the map phase because it's small size. And the query performance will be better, of course, because of the small size.
Good. So the buckets are to enable more efficient queries.